Who's excited about space? That's right. That's right. Do you think there's any ways that we could integrate space with blockchain? What about having new governance systems in space because it's completely greenfield? All right, there we go. Now we're going to talk about how we're democratizing connectivity over cyberspace with the dRTC network. I'm Shruti Appiah, everyone, and I advise Huddle team to build out the dRTC network, to design it, to build it, as well as to build out the cryptoeconomic systems that power it. Let's talk about how we are employing the dRTC network in order to democratize connectivity over cyberspace. We like to think of economic systems as complex systems. Complex systems are very much so affected by several nonlinear aspects and nonlinear dynamics as well. Typically, with nonlinear dynamics, you have things such as the butterfly effect. A butterfly flaps its wings in Bangalore, and you can feel its effects, and perhaps it causes a storm all the way in France. We can employ these kinds of complex systems principles in order to build really strong cryptoeconomic systems as well. So I'd like to introduce you to the concept of complexity cryptoeconomics, and I would like to also talk about how we're employing these complexity cryptoeconomics to build self-sustaining, robust, and resilient, as well as community-owned systems for the dRTC network. Self-sustaining is the ability for systems to be able to sustain without any external intervention. So systems that are typically able to sustain for a much longer time. This is not just talking about environmental sustainability, it's also referring to sustainability when it comes to system sustainability as well, for the system to be able to regenerate itself without the requirement for any external forces, external resources, or any sorts of external help, to simply put. Secondly, we also want to design the system in such a way that it's very robust to minute perturbations, it's robust to minor failures, and if it does fail, it fails safely, and it's also resilient. So small differences as well as small perturbations do not set the system astray. They don't set the system towards going into a poor state. And if it does, then we want to ensure that it bounces right back up without needing any external interventions as well. And finally, community-owned. Now, this is where we're building people-powered communication, and this is where we're able to ensure that this kind of a system is owned completely by the community, by the individuals that are operating within this system, and in such a way that they also own the means to production and can benefit by employing these means of production to provide services to the users of that system as well. Let's talk about the dRTC network. Next slide, please. All right, so this is what the new huddle system is going to look like. We have, at the base, we have the security layer, which is typically an L1. This is what we're going to be using for settlement of financial transactions. So all of the validation of these financial transactions are going to happen in that settlement layer. Typically, this can be a proof of stake type of system. On top of that, we have the execution layer. This is layer 01, guys, and this is something that Susmit and Ayush also touched on yesterday. This execution layer validates all the execution that happens on the networks that live above it. So execution of all of the meetings that happen over the dRTC network, as well, and it also ensures data availability. On top of the layer 1, we have the ability to build new marketplaces, to build more networks. The main network that I want to talk about today is the dRTC network, which powers communications, but we are also able to expand this to various other networks as well, such as finance networks. Maybe we can have a DeFi network as well, where we're able to create a decentralized marketplace for DeFi applications as well as financial instruments. And more networks, maybe we can also have a supply chain network as well. On top of this, on top of each of these networks, we have the ability to build dApps on top of the network. So today with Huddle 01, we're able to also build dApps using the Huddle SDK. And we want to ensure that we also maintain the ability to build more dApps with the decentralized architecture as well, where we're able to build dApps with a node-to-node architecture as well. That's the dApp layer. So you can see how this kind of, how the layers of the system are introducing a net new paradigm. The paradigm being the ability to build more networks, to build more markets as well. Previously, with layer ones, what we've seen is that they have opened up the ability to build decentralized applications, decentralized products, essentially. And those products were able to give users, developers, and entities the ability to generate profit from those products, as well as create new use cases and applications. With layer 01, we are giving people the ability to create new markets, new networks, which is what really excites me about it. Now let's talk about one of our most exciting networks, which is the dRTC network. The dRTC network is a market for communications. In this network, we have a marketplace of suppliers, which are the media nodes, and participants, which are the consumers of this dRTC network. The commodity that is being exchanged in this dRTC network is a dRTC minute. So a minute is essentially the minute that gets exchanged when you are having an audio-video call over the dRTC network. So anytime you have a call with your friend, every single minute of audio and video transmission is considered a dRTC minute. So the suppliers, which are media nodes, they're able to provide bandwidth and resources to supply these minutes to the participants. The participants then consume this, and they also pay a price to the media nodes. And thereby, the media nodes get rewarded for participating and providing these minutes, and the participants are able to enjoy an experience that doesn't compromise on things such as their privacy. It also provides a really smooth user experience, which is also quite decentralized as well. You might also be familiar with the phenomenon of how several companies in the Web2 space, such as Zoom, Google Meets, and so on, they really are compromising on users' privacy as well as profiting off of users' data by selling their data that gets transmitted through all of these audio-video minutes. But in this kind of a system, we don't do any of that, and thereby it's a net new experience for the participants as well. So there we go. The dRTC network is a multi-sided prosumer marketplace for audio-video calls as well as streaming. Let's look at the supply side. On the supply side, we've got the media nodes. These are the primary suppliers. Media nodes basically own specific amounts of infrastructure to be able to supply bandwidth, to be able to host any kinds of audio-video calls. And by supplying these dRTC minutes, they earn media node rewards. On the right side, you can see the unit reward function for the media node, which is the unit reward that gets paid per the dRTC minute. The factors that affect this are things such as availability of the media node over a long span of time. It also depends on the history of operation of the media node, as well as the quality of your operations as well. So they are independent latency as well as latency fluctuation behaviors over a span of time. And finally, it also is affected by the quality of service of that particular meeting that just happened. So when a call gets rewarded for, then certainly the call quality of that particular call also gets factored into the unit reward. And so I know this looks a little bit intimidating perhaps, but if you're all mathematically inclined, this is quite simple actually. It's simply a sigmoid function which includes a weighted sum of all of the factors that I mentioned in human language right here. And finally, we're also able to cover and scale for various different product priorities. Some of our product priorities are that we want to ensure good coverage in areas where there's a high amount of network activity, and good coverage in areas where there's a lot of demand for these minutes as well. So we want to incentivize media nodes to participate in these types of areas even more, so that they are able to provide lower latency in these these locations and localities as well. So we scale for even coverage across areas as well as across high demand regions as well. Next, let's talk about the demand side. On the demand side, we've got the participants. The participants are people like you and I. We participate in meetings. We thereby, by participating in meetings, we also consume dRTC minutes. These dRTC minutes, if we want to consume them, certainly we have to pay a small price in order to participate in these meetings, and so they pay that price. The unit price of these are expressed on the left side of the slide here, and the unit price is dependent on very few factors, primarily those being the quality of the experience that you have through that call. So if you don't have a lot of jitter, if you don't have a lot of interruptions during the call, then the quality of the experience is fairly high, so that will get reflected in the price as well. And then finally, we just compute the call price by computing and multiplying the unit price for the dRTC minute with the number of minutes that you have had the call for. And optionally, we can also apply surge pricing, similar to how ride-sharing apps apply surge pricing as well. We can apply surge pricing based on the demand in certain localities, and that we can use to measure demand. What we can use to measure demand is essentially the network activity. Now let's talk about what's even more exciting at a higher level, which is Layer 01. Layer 01 gives us the ability to host markets. We're moving beyond the ability to just be able to build dApps on blockchains. Now we're able to not only build dApps, but also build new networks and new marketplaces which operate completely with their own cryptoeconomics, with their own policies for the monetary systems. They operate on their own policies for incentivizing the supply side, as well as bootstrapping the demand side of new networks. Let's look more into how Layer 01 supports the networks above. Layer 01 essentially is an execution validation system. The way that Layer 01 validates these executions is by ensuring that the information that is supplied by the participants of meetings is consistent with the information supplied by the participants, by the suppliers of these meetings as well. In very general abstract terms, essentially what the consumers are saying about their experience should match up with what the producers are saying about what they provided for the consumers. And if those all match up, then the validator produces a meeting proof, and that meeting proof then gets validated and gets added on to the execution payload as well. And so this execution payload will contain an immutable record of all of the previous meetings that have happened and the meeting proofs of those meetings as well. So it's essentially a history of records of all of the meetings that have happened over that network. So it's very simple. For the dRTC network, the data that we're capturing in order to generate these meeting proofs is latency, as well as statistics about the meeting. So latency, the set of latency factors includes things such as just the ping latency, as well as latency fluctuations, and meeting statistics includes things such as the room ID, as well as the number of minutes that have been consumed through that meeting, as well as the quality of those minutes as well. So here you can see the participant A submits a party A submission, party A sub, and then the participant B also submits a party B sub, and then the media node submits a media node sub. Then all of those subs go into Layer 01, and Layer 01 ensures that the information that is submitted by all three of these parties is consistent with each other. And if they are consistent with each other, then this gets validated. That essentially then goes into meeting proof that gets validated and goes to the execution payload. And that's how we prove execution. This type of system, this validation system, can be applied across various different types of networks as well. I just explained how this works on the dRTC network, but it can also work on various different types of other use cases as well. So it can work for communications through this way, but it can also work for maybe a DeFi network where we're building financial instruments as well. Now, in order to do validations, we need validators. Validators are also expending effort in order to validate the information that's being submitted by the participants on the network. So when validators are operating, they also need to be rewarded. The way that these validators are rewarded is through block rewards. Block rewards get minted, so every time a validator validates successfully, then we reward them with tokens that are just newly minted. These minted tokens are minted based on our own monetary policy as well. Our monetary policy controls everything from the inflation rate to the amount that we want to be, or the desired stake ratio within our staking ecosystem, as well as the current stake ratio, and what's the relationship between those two, and also how much money is circulating through the system at that particular time, so that's the circulating supply, and finally the number of blocks that have been generated every year. And once the amount that needs to be minted for each block gets computed, that amount gets then gets sent to the validator. So validators, at the end of the day, they generate meeting proofs, and for generating these meeting proofs successfully, they get rewarded with block rewards, which are newly minted fresh tokens. I hope that gives a little bit of an overview of how Layer 1 works, because with all of these, technical things, what we want to ultimately build is a system that is able to encode human rights, digital human rights, in a very intrinsic manner within the system itself. We are very much so programming all of these rules into our system in such a way that digital human rights are just automatically ensured by the notion that these policies are embedded within the contract itself. And of course, these are all strictly enforceable because they are operating using smart contracts. And since they are strictly enforceable, we're able to very smoothly execute our Layer 1 manifesto. Our Layer 1 manifesto being systems, we want to build systems that are self-sustaining, robust, resilient, as well as community-owned. And folks, that's how we're building people-powered communication at Huddle. Thank you.